Welcome, chemistry students. Today we're going to start our journey on metric conversion calculations. And to start this journey, we're going to be converting between units of the same measuring system. There's a couple things you need to know. One, when one or more of the units involved is a base unit, a simple one-step calculation is possible. Two, conversion factors for the metric system, because they're the same measuring system, have infinite significant figures and do not affect our rounding. Let's take a look at one of the problems. So here is a problem. We have been given 1 liter and we are looking for how many deciliters. So let me put a little question mark there. Like, that's how I think about it. I go, how many deciliters is that? Okay, so let's do it. So we start out with our 1 deciliter and we find that there are 10 deciliters. Cool, not too bad, except what's going on here in the middle? Let's take a look at that by going back to the previous slide. This is a metric prefix chart. We are going to ask you to memorize all of these prefixes to help you solve problems this year. So one of the things that's really important about this chart is being able to remember and use it, to be able to look at it as a reference. So we have a prefix. Prefixes come before the base word. So kilo, hecta, deca, deci, centi, milli, micro, and nano are all prefixes. Each prefix has a symbol, all right? And the symbols are written here. These prefixes have meanings. Kilo means 1,000, and 1,000 can be written as 10 to the third. We could look at centi. Centi with a C means 0.01, and it's represented with a 10 to the minus 2. When the prefix is larger, it's going to have, like if it's larger than 0, it's going to have a positive exponent, right? Which means 1,000, 100, 10. When the prefix is less than 1, it's going to have a negative exponent, which means a decimal, 0.1, 0.01, 0.001, and so on and so forth. The prefixes that we are looking for right now, for the problem that we just did, is deci. So how we use this system is we would say let's see, can I write it right here? I'm going to say a deciliter is equal to, and so I look, what does deciliter mean? Well, I could write it as 0.1, or I could write it as 10 to the minus 1. So it's equal to 10 to the minus 1 liters. And what that means is that this is smaller than a liter, all right? It is 1/10 of a liter. And that is what we're going to use to solve our problem. So let's take a look at the problem that we just solved. So can we see here that we said a deciliter, we looked at our reference sheet, is equal to 10 to the minus 1 liters. So we let the units tell us what to do. So if I have a liter here and I want this to finish in deciliters, then liter has to cancel. And so I put liters downstairs and I put deciliters upstairs first, and then I add in my numbers. So where there's a deciliter, I write 1. Where there's a liter, I write 10 to the minus 1. And so I then can cancel the units that are like, and it leaves me with deciliters, which is a signal that I have answered the question, and it's time for me to do my math. So I take 1 times 10 to the minus 1, and it's going to give me 10 deciliters, which then we will box out that answer. All right, let's try another one. In the next question, we have been given 5.64 grams. In my mind, how many kilograms is that? In order for us to answer this problem, there has to be a relationship between grams and kilograms. So we're going to start by writing down 5.64 grams. That is our starting point because that is what was given, all right? We're gonna hit times. We're gonna put a division bar. Let me also say grams is a base unit. And remember, anytime we have a base unit in our calculation, we automatically know it's a one-step problem. So it's going to have a direct relationship. We know we are looking for kilograms. So we want to figure out like, okay, where do my grams units need to be? Where do my kilograms units need to be in order for me to solve this problem? Well, if I have grams here, in order for it to cancel, it has to be down below, and kilograms has to be above. Go there. Let me push that out a bit. Okay. All right, now we can look back at our base unit, or our metric chart, excuse me. We're gonna look back at our metric chart. So let me go back here a little. Nope, that's not what I wanted. Okay, so we need a relationship between grams and kilograms. Well, grams is a base unit, so we can come up here to kilo. And remember, we always put the number 1 in front of the prefix. So a kilogram, I'm going to go ahead and abbreviate now and use the abbreviations because that makes it easier for us to work with, is equal to, now the multiplier is 1,000 or 10 to the third. So it's equal to 10 to the third, and we always use the base unit on the multiplier. So the prefix gets a 1, the multiplier or the power of 10 will always get the base unit. So 1 kilogram is equivalent to 1,000 grams. So it is bigger than the gram. So coming back to our original problem, we have our grams here. We had our grams written, we had our kilograms written. All we have to do is put in the power of 10 and the 1 and then do our calculation. When we get this answer, you're going to find, I think it comes up here pretty quickly, but because this number is less than 0.1, we do have to put it in scientific notation, which means we need to move the decimal point 1, 2, 3. This number is less than 1, so that means it's going to be a negative exponent. So when we put it into scientific notation, it is 5.64 times 10 to the minus 3 kilograms, and we then box that out.